reading voltages on an analog meter. Okay, let's analyze the setting that we have here. What we have is a mock-up of an analog meter with different scales. So this is the display, this is our display. Here's our needle that is going to deflect according to the measured value. And we have a range selector which is pointing to 50 volts DC, which means that this meter as it is set up is capable of measuring DC voltages of up to 50 volts, which means that if the leads that are plugged into the port, these ports, if they are put across the measured voltage, and if that voltage is equal to 50 volts, we are going to get the full deflection of a needle right here. Well, right now we have the needle deflected not fully, but somewhere within the scale. What do we have in on the display? The top display, the top divisions marker, or the top scale, if you will, is the resistance scale. We are not going to use that right now. Right now we're using the voltages scale. So what do we have? Oh, here it says DC volts and amps. Okay, well, we're measuring DC voltages, so we're going to use this division marker right here, and we're going to choose one of the three scales that we're going to perform the measurements with. And the bottom scale, it says AC volts, but we are not measuring the AC volts right now. We are measuring the DC voltage. Alright, so I got a little bit of a scheme to go by, or the method. First, well, we have the range selected. So we are measuring DC voltage, and we know, let's say, that the voltage that we are measuring is somewhere between 0 and 50 volts. Alright, simple enough. So once we perform the measurement, we connect the leads onto the load across which the voltage appears, and the needle deflects this far. Alright, so if you choose this method that I'm showing you right now, it is going to be easy for you to use the analog meter. Alright, also, I haven't mentioned, this gray area that I'm pointing to right now, this in reality it's a mirror. Why do we need the mirror? Well, the needle is not tight against the display, the physical display. It's raised a little bit, it's offset a little bit. So if you look at the needle under an angle, you would get a different reading. So if you look at from this right side here, you might think that the voltage is less, or the needle deflects less than it actually does. Or if you look at from this angle, that way, you would mistakenly read more than the needle points. So the idea is to look straight down at the needle, and the mirror helps us to do that, because well, if we match the view of the actual needle and its reflection in the mirror, if they cover, that means we're looking straight down. So that's why we have that mirror. All right, so we have the division markers, and we have, for the DC voltages, we seem to have three different scales that we can use to read the voltage that we are measuring. So on the top we have a scale of 0 to 10, and this is just a number for now. Treat it as a number. Then the middle one is 0, 10, 20, 30, 40, up to 50 volts. And the bottom scale is 0 to 250 volts, depending on the on the value of the voltage, we're going to choose the scale appropriately. And how do you choose the scale? I mean, we're going to choose the range appropriately. This is the range selection right here. If how do you know which range to choose? Well, we're trying to accomplish almost a full needle deflection, and when the needle is in about this area, then you can get the most accurate reading. If the needle deflects just a little bit, then yes, you're going to see that it's approximately something between 10 and 20 volts or something like that, but you will not know whether it's 10.1 volt or 10.2 volts. Over here, you'll be able to get more accurate reading. Okay, so we have the range chosen, and the needle has deflected this far. So here's the method. Choose the scale, then throw the range on the scale. This will give us the multiplier, and then read the needle on that chosen scale and multiply that reading by the multiplier. Until we multiply that number by the multiplier, all we have as a reading is a number on that scale. It's not the actual voltage, not necessarily. This is easy to remember. I said throw the range on the scale. We always, because we have the range and we have the scale. What do we divide by what? Well, here's a thing that's easy to remember. If you go to a store or a supermarket and you buy some loose product and you come to the cash register, so they will throw that product, that loose product, that whatever you got, they will throw that on the scale in order to find out how much it weighs and so much to charge you. So it's something that is going to make it easier for you to remember. You throw things on the scale, so the scale is on the bottom. And once we divide the range by the scale, which is we are throwing the range on the scale, that will give us the multiplier. And we will use that multiplier. So once we get the reading, we're going to multiply that number that is being shown on this scale by the multiplier, and that is going to be our voltage. Okay, I said it twice. All right, let's see a first example. I'm going to turn this on. Here's our first example. Let's say we are going to choose the scale of 50. Well, it makes sense. The range is 50. And do we have a scale that says 0 to 50? Oh yes, we do. So why don't we use the middle scale and just get the reading? Because here it is. Here's the idea. So we chosen the scale. We're going to choose the scale of 50 because range is 50, so it's going to be the easiest for us to get the reading. Alright, but if we use that method here, so we're going to throw the range on the scale. Throw the range on the scale. So that range thrown on that scale, so it's just like range over the scale, range divided by the scale. Of course, that is going to give us 1 because 50 divided by 50 is 1, so the multiplier is 1 in this case. Okay, what do we have? I just wrote that here, the reading is 37. Alright, well, is it 37? Let's see how we got that 37 number. Okay, here's the needle deflection, and we are using the scale of 0 to 50. Let's see what the needle points on the scale of 0 to 50. So here's 30, here's 40, so which means somewhere here right between that it's going to be 35. Okay, let's see what the smallest division is. Is it 1? Let's try 1. 1, 2, 3, 4, 5. Okay, so we have determined that the smallest division when we're using the scale of 0 to 50 is 1. Okay, so here's 30, here's 35, 36, 37. So our number is 37, our reading is 37, and our multiplier is 1. So 37 multiplied by 1 is 37, so the voltage measured is 37 volts. Well, it makes sense because the range is 50, the scale is 50, so we just get the reading. Easy, okay? Now, can we get the same measurement? Are we going to get the same result if we use different scale? Well, by using this method, we should get the same result if we choose different scale and we use that method. Okay, let's try the second method. Here it is. Okay, all right, so let's choose the scale of 10. Okay, so what do? We throw the range on the scale. Range, scale, right? 50 divided by 10 equals 5, so our multiplier is 5. What is the reading on the scale of 10? Here. Alright, let's see. Okay, so this needle is somewhere in between 6 and 8, so let's find out what the smallest division is on the scale of 0 to 10. Okay, 6, 7, 8. Okay, here's 6, here's 8, so this must be 7, right? Well, right. Okay, so let's try this. 6.2, 6.4, 6.6, 6.8, 7. So 0.2 is the smallest division on the scale that numbers 0 to 10. So here is 6, here's 7, 7.2, 7.4. That's how we got that 7.4 reading on that scale. So it's just a number until we use the multiplier. So if you take your calculator, if you do 7.4 times 5 equals 37. Let's prove that, shall we? Just for kicks. Here's a calculator. So here's 7.4 times 5. Oh, look, it's 37. All right. So, of course, we're going to get the same reading. We're just using a different scale to get to that reading, but the voltage that we're measuring stays the same. The voltage that we're measuring, it is what it is. We just have to find out what it is, and we can use different scales, whichever is easier. If, of course, in this case, you would just use the 50 because here's a range 50, but I'm trying to show you that it doesn't matter which scale that you're going to choose, and sometimes you're going to have to apply this method. Okay, so we have the third scale here. Let's just do it. All right, so here is the third scale that we're going to use, 0 to 50. So the range is still 50. We haven't changed that. The needle still has the same deflection, which means the quantity is the same that we're measuring. Okay, so let's see. Choose the scale. Okay, so we choose the scale of 250. So this is the bottom set of numbers that we're going to use, and still we are applying this division marker right here. Alright, so the range is 50, the scale is 250 right now that we're going to choose that scale to measure it on. So throw the range on the scale. Throw the range on the scale. 50 over 250, and that gives us 0.2. So our multiplier is 0.2. Good. Now let's get the number on that scale that the needle points to. So this is the scale we're looking at. Okay, again, let's see what the smallest division represents on this scale of 0 to 250. Okay, so we have 0, 50, 100, 150, 200. So here between 150, halfway between 150 and 200, this must be 175. Let's see what we can get. Alright, so 150. Let's try this. 5, 10, 15, 20, 25. Okay, that would make sense. That's 175. It's 25. So 150 plus 25 is 175. So that's good. So we have just found out that the number that the smallest division is assigned to on this scale is 5. Okay, so let's try that. 5. 150 right here. 155, 160, 165, 170, 175, which, yeah, okay, 175. So let's go keep adding the fives. So 175, 180, 185. So our reading on that scale is 185. Alright, so it's still just a number until we put it against the multiplier. Alright, so 195 times 0.2. Well, I have a 37. Is it true? Okay, 185 times, what is our multiplier? 0.2. 0.2. And look, it gives us 37. Of course it's going to give us 37 because the measured value is still what it is across those leads. Okay, so this is how we use analog meter, and we apply different scales to get different readings.